Good day, students. In this clip, we're going to be going over three examples on how to find limits involving infinity. So let's go ahead and write down the instructions for the three examples. So the task is to find the following limits for question 1 to 3. To find the following limits. All right, number 1, we're going to find the limit as x approaches infinity of 3x to the fourth plus 2x minus 5 all over, let's do that again, all over 3x to the third plus 2x. All right, so we're going to do this using three methods. We're going to find the limits using three methods, okay? So find the following limits. Um, I'm going to add some more instructions, but to do this using weights, that's method 1, using weights. Method 2, division and uh, term by term limits. Term by term limits. And the last one is by uh, the end behavior model. Okay, the end behavior model. Okay, so let's go ahead and start out method 1. Method number 1 is the method of weights. Okay, all right, so let's take a look at this problem. Uh, what can we say about the weights of this polynomial, the numerator and the denominator? Well, remember the rules that if the polynomial, the uh, um, rational expression, if it's top heavy, the limit is basically plus or minus infinity. If they're equal weights, you just divide the leading coefficients, and then if it's bottom heavy, then the whole thing is simply going to collapse to 0. Okay? So it's either going to be top heavy, bottom heavy, or they're going to have equal weights. So what is the weighting of this rational polynomials? If you take a look at it, this rational expression, the biggest exponent on the top is x to the fourth. That's the biggest power on the top, or the degree of the numerator, and the degree of the denominator is the third, because that's the biggest power in the denominator. So since the biggest power on the top is bigger than the biggest power on the bottom, it's going to be classified as being top heavy. Okay? So what do we know? Well, we know that a limit as x approaches infinity of 3x to the fourth plus 2x minus 5 over 3x to the third plus 2x is either going to be plus or minus infinity. Okay? Now, if you take a look at this, since the two uh, terms that we're looking at with the biggest degrees are both positive, and the limit is also positive, then we can simply deduce that this one is actually going to be positive infinity because there's no negative here. Okay? So the weights doesn't always tell you exactly the limits, but in this case, you can make a reasonable guess that it's going to be positive without any calculations, because the first term, the biggest degree on the top is positive, the biggest degree on the bottom is positive, and the limit itself is positive. So there are no negativities here. Okay, so the limit is infinity. Now method 2, we're going to use uh, the term by term limits. Okay, term by term. We're going to divide and then use term by term. Okay, so let's go ahead and write down the limit again. We're trying to compute the limit as x approaches infinity of 3x to the fourth plus 2x minus 5 divided by 3x to the third plus 2x. Now, uh, first thing we're going to do is we're going to divide. What do we divide by? We're going to divide by the biggest exponent in the denominator without the coefficient. Okay, so the biggest exponent in the denominator is x to the third. So I'm going to divide the numerator and the denominator by x to the third. All right. Another way to divide by x to the third is by multiplying by the reciprocal of that. So I'll multiply the numerator by 1 over x to the third, and then multiply the denominator by 1 over x to the third. Okay? Why did I do that? That's the biggest variable exponent in the denominator. Okay, so now what I'm going to do is distribute this to all three terms in the numerator and the denominator. Okay, so if I do that, this whole limit is we're gonna have the limit as x approaches infinity of 3x to the fourth over x to the third plus 2x over x to the third minus 5 over x to the third, and that whole story divided by, in the denominator, you're going to have 3x to the third divided by x to the third plus 2x divided by x to the third. Okay? Now we're going to use the properties of exponents to simplify these terms that we have right here. Okay, so let's go ahead and do that. So we're going to have the limit as x approaches infinity. Here, you just subtract the smaller exponent from the bigger one. The bigger one is on top, so you subtract this 3 from the 4 upstairs. So it's going to become 3x, because 3 minus 4 is 1. 3x to the 1, you don't put anything there, plus, and then this one is to the first power, and this is to the third power. You subtract the bigger one from the small one from the bigger one. So since the bigger one is downstairs, you subtract the top from the bottom. So you're going to have 2 over x squared. This one, you don't need any reduction here, so it's 5 over x to the third. Okay, now that whole story divided by, in the denominator, this one's just divide out. You have 3 plus, and then here, 2x to the first on the top here, and then x to the third on the bottom. So you subtract this one from the 2 downstairs. So 2 over x squared. Remember, you always keep it where the bigger denominator, the bigger exponent is. Okay? Now that we've divided that out using properties of exponents, what we're going to do now is input this limit into the variables. All right, so if we do that, um, we're going to have 3 times infinity in place of the x plus 2 over infinity square, 2 over infinity square minus 5 over infinity to the third, and then that whole thing divided by divide that by 3 plus 2 over infinity to the second power. Okay, so there you have it. All right, so let's go ahead and simplify this expression with infinities. So 3 times infinity is simply infinity plus infinity squared is infinity, right? So we have 2 over infinity minus 5 over infinity divided by uh, 3 plus 2 infinity squared is just infinity. Okay, over infinity. Now, remember, anytime you have infinity as a denominator, you're dividing by infinity, that expression is going to collapse to 0. Okay, so this is going to become infinity plus 2 to the infinity is going to simply be 0 minus 5 over infinity 0 likewise divided by 3 plus 2 over infinity is 0. Okay, so this whole expression becomes infinity divided by 3, which is just infinity. So you see that the final answer is infinity. All right, let's go ahead and try method three. Method three is the one where we're going to use the end behavior model. Okay, method three, end behavior. All right, so basically, this approach relies on the fact that the the term with the biggest power in the numerator and the term with the biggest power in the denominator basically dictates how the rational polynomial function behaves at infinity, right? So limit as x approaches infinity of, let's rewrite the problem, 3x to the fourth plus 2x minus 5 over 3x to the third plus 2x. Now, the end behavior model is determined by the term with the biggest degree on the top, which is 3x to the fourth, and the term with the biggest degree in the denominator, which is 3x to the third. So we're just going to extract those two. So this limit is basically going to be the limit as x approaches infinity of 3x to the fourth divided by 3x to the third. So we just reduce this. This becomes the limit as x approaches infinity. You subtract the smaller from the bigger, so it's going to be 3x to the 1 is 3x over 3. You cannot reduce it any further. Oh yeah, we can divide it 3 too. So 3 goes here 1, 3 goes here 1. So you have the limit as x approaches infinity of x. So you just plug in the infinity into the x, so your final answer is simply going to be infinity. So we see that all our three answers match. All right, let's go ahead and take a look at question number 2. Question 2, we're going to find the limit as x approaches negative infinity of 3x squared plus 2 over 4x to the third minus x. Okay? All right, so let's go ahead and do this using method 1. Method 1 involves using weights. Okay? All right, so let's see. For this problem, if you look at this limit, you notice that the biggest the biggest term, or the biggest degree in the numerator is squared, x squared, and the biggest degree in the denominator is cubed. So since the denominator has the bigger degree, the term with the highest degree, this is going to be classified as being bottom heavy. Okay? So it's going to be bottom heavy. So if it's bottom heavy at infinity, the denominator grows rapidly in such a way that it totally exceeds the numerator and the whole term collapses to 0. So in this case, the limit as x approaches negative infinity of 3x squared plus 2 over 4x to the third minus x is equal to 0. Okay? Anytime you have a limit involving infinity and the denominator has a bigger degree, the limit is going to be 0. Okay? All right, that's using method 1, which is weights. Now let's go ahead and use method 2. Method 2, where we'll use term by term limits, term by term. Okay, divide and then we evaluate the limits of each term independently. Okay, so let's go ahead and rewrite the problem. So for question 2, we're looking for the limit as x approaches negative infinity of 3x squared plus 2 over 4x to the third minus x. All right, so we need to first of all multiply the numerator and the denominator by the variable with the highest degree in the denominator, which is x to the third, as you can see here. So I'm going to divide both the top and bottom by x to the third, or to make it easy, I'm going to multiply by the reciprocal of that, so multiply by 1 over x to the third in the numerator, and also in the denominator 1 over x to the third. Okay, I'm going to distribute that to the numerator and the denominator, so I'm going to have limit as x approaches negative infinity of 3x squared over x to the third plus 2 over x to the third divided by 4x to the third over x to the third minus x over x to the third. Okay? Now let's go ahead and reduce this using the properties of exponents. So remember, when you're dividing, you subtract, right? So we're going to have limit as x approaches negative infinity. You have a 2 and a 3 here. The bigger term is downstairs. The term with the bigger degree or the bigger exponents is downstairs. So you're going to subtract these two from the denominator. So you have 3, and the variable stays downstairs since it has a bigger power. 3 minus 2 is 1, so 3x plus. This cannot be reduced any further, so we'll leave it alone as 2 over x to the third. And then in the denominator, this x to the third is just divide out, so we have 4 minus, and then x to the 1 over x to the third, you subtract this 1 from downstairs since that has a bigger power. So you're going to have 1 over x to the second because 3 minus 1 is 2. Now we're going to plug in the infinite symbols, negative infinity. You have to be really careful with the sign here, negative infinity. So we're going to have 3 over negative infinity plus 2 over negative infinity to the third divided by 4 minus 1 over negative infinity squared. Okay? All right, so let's simplify this. You're going to have 3 over infinity. Remember, any number over infinity or plus or minus infinity is just 0. It collapses to 0 plus 2 over negative infinity cubed is negative infinity divided by 4 minus negative infinity squared is just infinity, so 1 over infinity. All right, now let's simplify this further. This is going to become 0. Now, 2 over negative infinity is 0. So 0 plus 0 over 4 minus 1 over infinity is 0. Okay, so we're going to have 0 over 4, which is simply 0. Okay. All right, now let's move on to method 3. So for method 3, we're looking at the end behavior. Okay, method 3 is using the end behavior model. So end behavior. All right, so for that one, we're just going to focus on the terms with the biggest degrees in the numerator and the denominator and evaluate that limit. Okay, so let's rewrite the problem. We have the limit as x approaches negative infinity of 3x squared plus 2 divided by 4x to the third minus x. So in the numerator, this is the term with the biggest degree. And then in the denominator, this is the term with the biggest degree. Okay? So what we're going to do is extract those two. And then this limit basically becomes the limit as x approaches negative infinity of 3x squared over 4x to the third. Okay? Now you subtract the smaller exponent from the bigger one. So this is going to become the limit as x approaches negative infinity of 3 over 4. The x goes downstairs. 3 minus 2 is 1, so 3 over 4x. All right, so now we're going to, since we can't simplify any further, just plug in the infinity into the expression. So we're going to have 3 over 4 times negative infinity. Okay, do some simplification here. 3 over 4 times negative infinity is negative infinity. And 3 over negative infinity is 0. Okay, so there you have it. All right, let's go ahead and take a look at another example. Question number 3. In this case, we're going to find the limit as x approaches infinity of 2x squared over 5 minus 3x squared. Okay? All right, let's go ahead and do this. Method 1. Method 1, we're going to use weights. Okay? All right, so let's examine the weights of the numerator and the denominator and see what we can conclude. So if you look at, remember we're focusing on the terms with the biggest degrees, okay? The term with the biggest degree on the numerator, there's only one term. The biggest degree on the numerator is square, and then the denominator is also square. So what do we have here? We have equal weights, okay? We have equal weights. So anytime you have equal weights, all you simply do is divide the two terms with the equal weights. So you just go 2x squared divided by negative 3x squared. You just simply divide it, right? When you divide these two, these variables cancel out. You just end up with 2 over 3 as your final result. Okay, let's go ahead and try another method. Method 2, which is using term-by-term limits. Method 2, term by term. All right, so what we're working on is the limit as x approaches infinity of 2x squared over 5 minus 3x squared. Okay, so now the biggest variable degree in the denominator is x squared. So that's what we're going to multiply the numerator and denominator by. So we multiply by reciprocal of that. So multiply the numerator by 1 over 3x squared. Okay, and then also the denominator by 1 over x squared. Multiply by 1 over x squared. 1 over x squared, and then the denominator by 1 over x squared. Then we multiply it out. You're going to have 2x squared over x squared divided by, distribute that to the bottom, we have 5 over x squared minus 3x squared over x squared. Taking the limit as x goes to infinity. All right, so if we simplify, we're going to have the limit as x approaches infinity of 2 over 5 over x squared minus 3. Okay, now we're going to plug the infinity into the variable. So we're going to have 2 over 5 over infinity squared minus 3. And then that's going to become 2 over 5 over infinity squared is 5 over infinity minus 3, which equals 2 over 5 over infinity is just 0 minus 3. The final answer is negative 2/3. Okay, and there you go. So you see that all our three answers actually match. So term by term. Okay, we actually have one more. All right, so the last one we're going to do is the end behavior model. Okay, so for number 3, uh, we're looking at method 3. So for method 3, we're going to be using the end behavior model. Okay. Okay, so that just means we're just going to reduce our problem into the two exponents, the two terms with the biggest exponents from the numerator and the denominator. Okay, so the question is limited as x approaches infinity of 2x squared over 5 minus 3x squared. Okay, so the term with the biggest degree in the denominator is negative 3x squared. We have to take with a sign, and on the numerator is 2x squared. So that's what the end behavior model is. So we're going to have limit as x approaches infinity. And the numerator is 2x squared. The denominator is negative 3x squared. Okay, we can reduce this. If you reduce this, you notice that it's x squared is divided out. This divides out. And then you're going to have the limit as x approaches infinity of negative 2 over 3. Since this number is independent of the direction of x, our final answer is simply negative 2/3. And there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. You can click like if you like the video, and please post a comment to let me know what you think about this presentation. More clips can be found on mathgotserved.com. Thanks again, and have a wonderful day.